Hello, my name is Chelly Charles. I will be presenting my findings on a research project. It's called Going Beyond the Test Scores, the Hidden Factors Influencing College Readiness. One more time, Going Beyond the Test Scores, the Hidden Factors Influencing College Readiness. And what I meant by hidden factors, I'm thinking about factors that not test scores beyond the standardized tests. So this project is focused on two aspects: exploring what factors besides standardized tests that play some significant role in students' college readiness. And two, can those factors be used to predict the college readiness scores? So when I mean those factors, we're going to divide those factors into students, non-cognitive factors, and parental factors. So what I mean by non-cognitive factors, it means personal attributes like motivation, teamwork, attitudes, social interaction, etc., that may help in the student's success in the college life and college experience. That study has been guided by two research questions. One, can non-cognitive school factors influence college readiness? How do families play a part in the children's college readiness? So these are the two research questions I'm going to use as a guide towards my project. From the data set, just take a look at the descriptive stats. Before pre-processing, I had about 300,000 rows of data with 22 columns. If you take a look at some of the numerical variables here, we have age, grade level, but pay attention to study hours per week and family income, which was highlighted. The reason why I highlighted it is because you can see that the mean and the median is quite a bit different. There's quite a bit difference between those values here, which sort of indicate that those variables, the data is skewed, whether it's left or right. And lastly, our target variable is the college readiness score, which is a numerical variable there. So we'll be using the regression models. If you look at the distribution, this histogram shows the distribution of the college readiness score, which is the target variable. And it is highly left skewed with mean of 90. As you can see, most of the data is around 90 to 100 and median of 99. What are the methods to go about this study? One, I'm going to divide it into two areas: exploratory analysis and two, predictive analysis. In exploratory analysis, I will use Pearson correlation and one-way ANOVA test, which is going to be used for the categorical variables. In predictive analysis, we're going to use linear regression, decision tree, random forest, and XGBoost. For each of the model, I also employ or use cross-validation, and that way cross-validation is used to help enhance robustness for the estimator and also help overfitting. So each of the model, I did cross-validation. So look at some of the results here. One, from the exploratory analysis, the grade point average shows that the correlation coefficient of 0.4 and the p-value, which is less than 0.05, that shows some significant statistical significance for the grade point average. That also goes with number of hours per week. But bear in mind, just focus on grade point average because of the correlation coefficient, which is 0.4, compared to the others, which was less than 0.1. For the grade point average, this is just a scatter plot here, which shows the dispersion of the points among the regression line. And that shows a weak positive correlation. Remember, it was 0.041. For the ANOVA, which deals with the categorical variables, I've highlighted here was the parental level of education. The p-value for that was 0.0, which is less than 0.05. And pay attention to the F statistics, which basically tells you about how significant is the difference between the groups of the parental level of education. So there is some significance there in the parental level of education, which maybe has some important role in the children's uh, college readiness. So I'm going to investigate a little bit more of that, maybe use chat to verify that. And even the extracurricular count shows some significance of 374 for the F statistics there. So just taking a look peek at the parental level of education, as from the bar chart, it shows that the higher the level of education of the parents, it does make a positive impact on the children's readiness score. As you can see, the higher the parental level education, the greater the score of their children. Likewise, the extracurricular count, the more you take part as a student, take part in extracurricular activities. And if you think about extracurricular activities, what it does, it may help in social interaction, maybe help in responsibilities. These are all non-cognitive factors, teamwork, group work. And these now, as you can see from the bar chart, the scores are increasing as you increase more extracurricular activities, peaking at number 3. So doing at least 3 extracurricular activity can help you get a bigger college score. Now, when we go to predictive analysis with the different regression tree here, just take a focus at the test, the mean squared error, and the R squared error, R squared value. The linear regression, most of the models except the linear regression perform well in comparison to the linear regression. Not well in terms of, exactly well in terms because it's only 21% for the R squared value. But in comparing to the linear regression model, the regression model was 17% compared to the other 3 models, which was 21% on the test data for cross-validation and just the regular train test split data. So does it make sense cross-validation? It was just an experiment to see, but realize that the values are almost the same. The result is almost the same. So let's conclude some of the findings from the data here. So from the conclusion, most of the data, we realized that most of the correlation coefficient were close to 0, which indicate no linear relationship existed between the predictors and target variables. Maybe there might be non-linear relationship. That's something that can be further investigated. In terms of parental factors, most of the impact we'll see significance will be the income of parents do have an important part there, and the parental level of education. And parental level education have more influence on the student's college readiness score than other factors. For students' non-cognitive factors, we have the amount of study hours per week, and extracurricular activities do have significant influence on the college readiness scores. And last but not least, because the scores were not too far apart, it might be easier to use a simpler model, such as maybe linear regression or decision tree. Instead of using the complex model like XGBoost, it might be easier to use decision tree since these models are easier to interpret. Coming down to the discussion limitation, something you need to take into consideration, even though some of the p-values of the variables were less than 0.05, which shows statistical significance, the correlation coefficient for numerical values or the F statistics were not significant. So you got to consider both aspects there with the p-value and those values, whether it's the R value or the F statistics. In the future, maybe pre-processing can be done to help data quality. That's something that can be looked into. And based on the data from the research there, from the results, there was a high degree of randomness for most of the variables there, which will show that the performance, which has shown in the result of the performance there. And in the future, as technology increases, so we can use nonlinear machine models can be used, or maybe we can use neural networks, which is quite pretty much rampant or in the making. That may help with increasing the prediction. So thank you very much for listening to my presentation, and I'm your host, Chelly Charles.